Okay, let's get this party started. Hey everyone, welcome to DevCon 29, and thank you for attending the demo of my tool called Frack. Now first, a quick note on logistics. Please post any questions in chat and we can discuss them in the Q&A session afterwards. Now a bit about me. I'm a security analyst at Orange Cyber Defense and we're based in South Africa. I've been in the IT sector for almost 20 years now, of which I've been a pen tester for 6. I've also developed a small hoarding problem with breach data over the years. I've been hacking and tinkering since I found the first edition of Frack magazine on a random BBS in the late 80s. Now, the reasoning behind Frack is that there's breach data everywhere these days, whether it's on the open internet or on the dark web. Now, since most breach data is usually in a terrible state, Frack will help you to parse this data and sanitize it. Leveraging Google's cloud infrastructure, Frack will also upload the parsed file to your cloud storage bucket, ingest the data into your cloud database, and finally clean up the cloud storage bucket. Now, using Frack, you can also query the data, and the results will be dumped into a spreadsheet for ease of use. Another big plus is that Frack democratizes the data, so both good and bad actors have got access to the same data, leveling the playing field. Now, with all the breaches dropping everywhere on the internet, there is definitely no stopping the signal. Now, there's several use cases for Frack, but it was developed with the following scenarios in mind. When you are doing a red team or an external assessment, the data is super useful for perimeter brute forcing and have several times led to perimeter infiltration. When doing phishing campaigns, it also helps to get an initial set of email addresses. Lastly, it's an awesome value add for your customers to add it to your reports, showing them which of their corporate accounts have been leaked and allows them to make sure they change the passwords of these accounts. Now, Frack consists of 3 main modules, the parse, the DB, and the query module. Now, using these 3 modules, you can parse your data, manage your database, and query the data, exporting the results to a spreadsheet. Now, unpacking the parse module, there's 2 ways to ingest the data. The first is by using the built-in CSV parser that can parse the CSV formats you see on the screen. Now, Frack also has a plugin system where if you find a database on the internet or dark web and wish to parse it, quickly do a SHA-1 of the data file and search the plugins page for that hash. If there's a plugin to parse it, you can just download it and it will parse out all the unwanted data. If you have issues parsing a dataset, you are more than welcome to contact me, and I'll give you a hand in creating a plugin for your dataset. Now, Frack uses the Google Cloud Platform as infrastructure because it's super cheap and very fast. All you need is one big query table and one storage bucket. Now, the basic Frack workflow is very simple. First, you find the data, then extract the data that you want, using either a straight CSV import or by using a plugin. The data is then compressed to Apache org format, so that the upload doesn't make you grow old. Once it's uploaded into your storage bucket, you simply initiate the ingestion of the data into the database using Frack. Now, Frack was created in Python, which makes it very easy to understand. If you'd like to add your own plugins to the repo, you are more than welcome to. The plugins are easy to create, as I'll show you at the end of the presentation. Now, Frack also makes use of the Apache org file format. That results in much smaller file uploads, and Google Cloud Platform supports org format natively. Now, why did I choose the org format? Well, there are several advantages to using the org file format. Firstly, it's natively supported by the Google Cloud Platform. It uses lightweight indexes and makes use of block mode compression based on the data type in the database. The resulting database is a single file format, so once again, it's easy to manage. Now, here we can see how effective the org file format compresses data. As you can see, our original file was 29.7 gig. When we then take the good data and add fields to it, so it'll make sense when we view it in the database, like the year and website, and we extract the domain from the email address to speed up the searching. Now, after that is done, we have a file that's 75.7 gig. Now, to upload this to the ingestion bucket will take a while, so we convert the dataset to org format. After the conversion, the file is 12.8 gig and much more manageable to upload. Now, let's take a look at the tool itself. First up is the parse module. Let's run through the flags quickly. -I is the input file you are going to parse, "-m is used if you are going to use a plugin. Now, if you are not using a plugin, you need to use the -y for year, -n for name, and -w for website, so that the data makes sense in the database. If you are not using a plugin, you also need to tell Frack what format the CSV file is in before parsing it. This is done using -p if your file is email password, or -s if your file is email hash salt. Now, during parsing, there's several sanity checks that I do on the data. First, I check if the email address is a valid address. Next, we look for fields containing no data, null bytes, and non-ASCII characters. But you get the drift. Now, all the lines of data that does not pass these checks can be dumped in a .error file, so you can investigate why they failed validation. The -u flag will upload your org file after parsing. Next up is the DB module. Now, this module is used to manage the data. We can count the lines in the DB and start an ingestion job. Adding the -d flag will auto-delete the file from the ingestion bucket on successful ingestion. Now, for the following three flags, we can export the output to a spreadsheet by adding the -f flag. We can query the top n passwords, what websites are in the database, and list all the breaches. Let me show you some examples. So here we've got the top 10 passwords. Sorry, that's in my current dataset. The blank one is probably entries with only hashes. Now, I still have to take that one out. But it looks like all the websites are correct with their analysis of the top 10 passwords. Next up, we've got the websites that's in the dataset. And lastly, we've got the breaches, with collection 1 towering high above the rest. And finally, we have the query module. Now, there's two flags in here, a -i to give it a file containing a couple of domains that may belong to the same customer, or you can do a -d to query a single domain. Let's do a query on a domain. I've chosen my work domain as they are less likely to call the cops on me. We've got the breach and website the data came from, a year column to show how recent the data is, and to allow you to remove old data from the database, should you wish to, for example, keep only data from the last 5 years. Then the important parts, the email address, password if there's a clear text password, and the hash if only the hash was leaked. Now, the spreadsheet also includes sheets that will give you the top 10 passwords for the specific dataset and a list of unique passwords, so you can start brute forcing as soon as possible. Next up, we have the quick guided run-through that's on the GitHub page, which will show you step-by-step how to set up and configure your Google Cloud infrastructure, as well as ingesting your first data using a regular CSV file, and I've added a SQL file in there as well. Now, there's sample data in the demo directory of the GitHub repository if you would like to ingest some data at home. So to configure Frack, there's 3 lines to edit to match your infrastructure. Then it's ready for action. Here you can see we're only using 1 storage bucket and 1 BigQuery table. And here's an example of our ingestion bucket containing some data before we've begun an ingestion job. But you don't have to worry too much about this. Remember, there's a step-by-step guide on the GitHub page. Finally, the plugins. In the plugin section of the GitHub page, we'll find plugins for all the major breaches with their file hashes and original file names to make it easier for you to find the data. The plugins are super easy to use. It contains 2 functions, process rows and row format. Now, the process rows will iterate through every line of the file. This is where you do your splits and some basic validation. In this example, we're parsing a raw SQL dump. So first we ignore any blank line and any line that does not start with an insert statement. Next up, we split the row in 2, one containing the values we're interested in, and the rest can be discarded. We split the row again, this time dumping every data line into a tuple. Finally, we iterate through this tuple, calling the second function of the plugin row format. Now that we've got a row of data, we simply extract the data we require and return it to the main function in Frack to do all the validation checks. That is really all there is to it. Now let's parse some data. Just switch to my console. Okay, and here we go. So first off, we need to export our credentials. That's configured on the Google Cloud Platform. That's usually a JSON file that get exported. So let's just search for that quickly. There we go. So now we can authenticate to our cloud infrastructure. So now, let me just open this. Okay, so let's take a look at the demo data. So first off, we'll do a normal SQL dump. So we can do the first 6 lines. And there you see we've got a table called fake containing emails and SHA-1 hashes. So let's parse it. I've added a plugin for this demo file. It's already shipped with Frack, so you can do this at home. Using the parse module, we would like to use module fake, and our input file will be demo and then fake.sql. And that's all there's to it. There you can see we've got 999,999 good lines and 1 bad line. So that is perfect. Now, I've also added a script in the GitHub repository called counter-awk. It's basically the head command for awk files. So let's quickly do a sanity check on our data. There you can see the first couple of lines of our data. Everything's in the correct columns and everything. And our line count is correct. Okay, so that's it for SQL. Now, let's do a raw CSV import. So let's take a look at demo directory again and hold it fake parse. And there you can see we've got email addresses and clear text passwords. So let's parse this with Frack. We will use Frack. We are going to use the parse module again, but this time we're not using any plugins. So our input file is going to be demo slash fake parse, and then we need to specify the website. I am up to o2.com. Give it a year. Just making this 1980 just to make it easier. And this breach was not part of any collection or any combo that was leaked, so that will be none. And we want to upload it to our ingestion bucket, and the file contains clear text passwords. So there we go. The file is already parsed. It's uploaded to the storage bucket, and there we go. Now let's take a quick look at our storage bucket. Let's just refresh this. Okay, and there you can see our file. So now let's do an ingestion. So we do frack.py. We want to use the DB module, and we want to do the ingestion, and we want to clear the bucket afterwards. And that's all there is to it. So now Frack will create an ingestion job on the back end, import that awk file into our big data database, and then it's ready to query. There we go, the job is finished. Let's have a look at our bucket again. Okay, and there you can see our bucket's empty. Now, let's query this data. So I'm going to do Frack. I want to use the query module, and I want to query a single domain. I am up to no good.com. And there it goes, querying our database. So now it will return all the line items that's from that domain and dump everything for us in an Excel spreadsheet. So the password analysis takes a while because it's 300,000 lines that it has to iterate through. But once this is done, we'll have a nice Excel sheet that we can send to our customers. So let's just wait for this to finish. Opening up the folder so long. Almost there. And we're almost there. And it should be close. My laptop started to spin up all its fans. So it's using every part of its brain. There we go. Okay, so now we've got our Excel file. Let's take a look at our Excel sheet. Just open this. There you go. There you can see our data. So if we scroll down, you can see all the passwords. So the random function on the password generator that I used wasn't very random, but yeah. There's our top 10 passwords with the accounts next to them and our unique passwords. So that's it. Let's get back to our presentation. Okay, my future plans for Frack. Now, even though I've been working on this tool for the most of 3 years, there's still some features I would like to add, so keep an eye on the GitHub page for these new features. I want to add the ability to query a single email address and to do bulk parsing to parse massive combos like collection 1. Then some DB maintenance commands to, for example, delete all entries from a specific year or a specific website. I would also love to partition the database. However, I still have a massive load of research to do before I can do that. Partitioning still have some kinks I need to work out, but will eventually make the query smaller, resulting in even cheaper running costs. I would also love to add a web front end to the project with user management, but once again, I'll have to do some research because I suck at web design. Finally, a quick hat tip to Apache, who created the org file format, the Python PyOrg library created by Noirello, and Leon JZA for all the support and mentoring, and then finally to all those who have come before me, keeping the signal going. That, my friends, is Frack in 20 minutes. I hope you enjoy it and that it can add a lot of value to your assessments and to your customers. Live long and hack the planet.